very quickly. So the TensorFlow, who knows TensorFlow? Who doesn't know TensorFlow? Okay, so it's kind of 50-50 almost type of thing. So this will be a high-level introduction, so don't worry. And what I will do, I'm going to start first with a 2-minute video. Yes.
Funding for MIIA, or do you look for project-specific funding?
If you look at, good question. Yes, you will see on the website sponsorship, we are looking at donations, like any non-profit. So there's ways to do that. There is grants that we're looking at applying for. We're looking at project-specific funding, absolutely. And there would be a lot of that, I think, especially if you collaborate with other community, other partners and stuff like that. You want to focus on international inclusion, for instance. So let's do something there. Then there's quite a bit of stuff on technology. We already have technology donations, platform stuff. We're using Slack, we're using a bunch of other things as well. So Google for non-profits, registered for that, same again. So that one as well. So it's all things, definitely. Yeah. Okay, so I'm going to start. Hopefully it's going to be loud enough.
Deep learning is this branch of machine learning loosely inspired by how the brain works. We have had experience building software for deep learning over the last few years. Although it was initially a research project, we've since collaborated with about 50 different teams at Google and deployed these systems in real products across a really wide spectrum of areas. Today, it's used heavily in our speech recognition systems, in the new Google Photos product, Gmail, in search. We've really taken all that experience and built that into TensorFlow. TensorFlow is this machine learning library that's used across Google for applying deep learning to a lot of different areas, doing both artificial intelligence research and deploying these production models. They're really powerful at doing various kinds of perceptual and language understanding tasks. These models are able to actually make it so you can actually see, or are actually able to understand what is in an image when you're looking at it, what is in a short video clip. And that enables all kinds of powerful product features.
Machine learning is the secret sauce for the products of tomorrow. It no longer makes sense to have separate tools for researchers of machine learning and people who are developing real products. There should really be one set of tools that researchers can use to try out their crazy ideas, and if those ideas work, they can move them directly into products without having to rewrite them.
On the research side, the goal is to bring new understanding to existing problems, advance the state of the art on existing problems, understand new problems that weren't considered before. Then on the engineering side, the goal is to take those insights from the research community and use them to enable products and product features that wouldn't have been possible before.
Part of the point of TensorFlow is to allow collaboration and communication between researchers. It allows a researcher in one location to develop an idea and explore it, and then just send code that someone else can use on the other side of the world.
We are making it a lot easier for humans to be able to use the devices around them. We think having this as an open source tool really helps that and speeds that effort up. So we expect developers to be able to do a lot more than they can do today.
We think we have the best machine learning infrastructure in the world, and we have the opportunity to share that, and that's what we want to do here.
That's a nice introduction. So what I would like to do, and Alex, you mentioned, here. So before I've got a few slides, I'm going to start with the TensorFlow Playground. And if just see. So Alex, you played with it. You want to quickly? Alright, this is going to be super quick. This is actually very. No, you want to relax. Okay. So who knows? Who worked with neural nets? I've seen a neural net. Okay. So in like 50%. So this is it. Basically, what I will do with TensorFlow is very high level. So you would, even if you don't know anything about neural nets, it will be very easy. This is just showing. There's a little bit of a playground with TensorFlow, and what they've got here is a very. You can actually build your neural network. You don't need to know almost anything about neural networks actually. All the parameters. There's lots of parameters on top there and down there that you can adjust. So basically, this particular problem is a classification problem. And basically what you would like to do, and actually what I should do is just go back, reset the thing. You've got two classes. You can set the different classes. You've got the blue dots and you've got the orange dots. And you would like to train a neural network to actually do the separation and do the classification perfectly, if you can. So what you do is you obviously, this is just two-dimensional, so you feed in x and x2, the coordinates, effectively. You can create features there of that, but that's the features, effectively. And then you can create these hidden layers. You can stack them up. You can really make them deep. So you can just increase them. And then you've got outputs. And outputs is just for the classification, either orange or dot or a blue dot. So what I'm going to do, I'm going to press that play button there, and it will go through iterations. And basically it's going through cycles through the data. And what you will see is kind of the output here, you will see a test loss. So currently when you start, it's 0.5, and the training loss is 0.5. But you will see a training curve, a test loss and a training loss curve here. And you will see how quickly it learns, so it reduces the error. And you also will see how it actually starts to learn to get the classification right. So it's very simple, and it will happen probably in a few seconds. So I'll play it again if you want to see it. So I'm going to press the play button, and you can see it goes down all the way. The error is going down to almost 0.06, 002. That's on the test set and the training set. It actually get it perfectly right. So you can see the orange and the blue is the neural network classification. So it started initially randomly, reduced the error quickly. You can play with it, it's super easy. So it gives you a feel for doing all sorts of different things. It's still continuing, we can stop it. You can reset it, train it again. You can play with learning rates, activation rates, regulation, regularization. You can set the regularization rates, you can do all sorts of different things. I'm not sure if you can do drop down and stuff like that. Yeah, I don't think you can, but anyway, so you can play around with the noises and stuff like that as well. So cool. Behind this is TensorFlow, so they just made this front end from the web browser you can play with. Okay, so let's go to the slides. We've got 7 minutes. So Google has given you an introduction to TensorFlow always in 2 minutes. So that's already a high level introduction, and I think you should know more or less what it's about. We showed you the playground. So I've got just a quick introduction. So what is TensorFlow? Open source software library for numerical computation using data flow graphs. So this is a very simple example of a data flow graph, where you can see you've got nodes and you've got edges, and you can see data is flowing through the network. So A and B, you can see C is equal to A plus B, B feeds into D's B plus 1, that type of thing. So this is obviously a simplified example, but TensorFlow is just that. It's really simple. But obviously we talk about the flow of tensors. And tensors is dynamically sized n-dimensional arrays, so vectors, matrices, 3D tensors, and I'll show you a little bit about that. But what's cool about this, it's got a flexible, scalable architecture, so models can run on phones, models can run on computers and distributed systems. It offers drastic reduction in development time, all really good, cool stuff. And this is what it looks like. So you will see the flow. So I've got this GIF where you can see the nodes and you can see the edges. And the edges is effectively the tensors, data. And this is just a flow of tensors through the graph. So it looks at that neural network and it just do all the calculations effectively being represented with this data graph, effectively. Now, tensors, if you look at the image, for instance, a 3D tensor, obviously, if you look at the image, you've got rows, columns, you have color. So 3D, so you can feed that in. So you can represent that with a three-dimensional tensor. So that describes the I/O relationships. And then on the nodes, that's operations, the mathematical operations. So the neural network, you want to calculate a gradient, you want to do all those type of stuff, you want to apply activation functions and so forth. So this is just operations applied to data flowing through. And the nodes could also be endpoints to feed data, push output results, all of those type of stuff. Okay. In the interest of time, I'll just quickly go on. And some of the key features, it's really flexible. So you can just add your own stuff, operations on top of the TensorFlow framework. It's truly portable. So you can see it sits on top of CPU, GPU, Android, iOS, all of that. So it's easy to go from research to production. Auto differentiation is quite a bit of support for different auto differentiation, so it makes grading descent algorithms and stuff easier to do. There's language options, C++ and Python. I'm a big Python fan. I know there's some people here from the Python community. As a matter of fact, Simon, you actually coordinated, there's a PyCon conference. PyCon? Yeah, he's involved in that. When's that? October. Okay, we put it on the website as well, so people know. Okay, so maximize performance, and then obviously parallel execution supports that. And I just want to show you some examples of solutions with TensorFlow. Google is, as you heard in that video, use it for search, advertising, speech recognition, photos, YouTube, translate, maps, Street View. In Street View, you saw the blurring of the house numbers, the car registration numbers. That's all been done with deep learning, TensorFlow. They've got standard type of examples that comes with TensorFlow in this handwritten character, handwritten digits recognition. But you can do awesome stuff with visual object recognition. Even if you think about natural language processing, there's vector representation of words, and once you've done that, you make the task of natural language processing so much easier, which is awesome. Have you played it?
Yeah, I did my thesis on this word to that, so like.
Oh, really? There you go. So you know some nuts and bolts of that. Then object recognition, machine translation, all these kind of applications, and you probably saw these type of stuff. There's quite a bit of companies also doing this, where you see machine learning looking at pictures and giving captions. For instance, a man holding a tennis racket or on a tennis court, two pizzas sitting on top of a stone, top of it. A group of young people playing a game of frisbee. This is interesting, a man flying through the air while riding a snowboard. That's creative. So, anyway, so in the interest of time, there's a nice example here that goes through it, but it's really simple to use. What I will do is I'll make the slides available also on the website and on Slack, so you can go through this. This is kind of a summary, just showing that in this example, how easy it is to actually implement this TensorFlow. Just going through all the different steps. So I think I'm probably going to end with that. The rest of the stuff here is okay. Do you have any specific questions? I can go into the more detail if people want to, maybe afterwards as well. Yes.
Just
yes.
comment. As far as I understand,
yes.
A big part of the strength of TensorFlow compared to other libraries is that you sort of define the model separately to the backend C,
right,
and then hands everything over, so you don't lose computational speed at the interface between Python and C.
Exactly right. So if you look at I've got my final slide. It actually builds the graph, everything's set up. Then it initializes a session, so it creates a session for that, and then it fetches and feeds the data with a session.run. So it's actually conceptual, semantic, or just representation of this whole architecture. It sets it up effectively for execution and stuff. And that's the architecture is just great. It's a flexible, scalable architecture that allows that. I've got actually one presentation, I can put it on the website, that shows all the comparisons, the weaknesses and strengths. And there's some weaknesses with TensorFlow that has been addressed, especially in terms of performance and stuff like that. And Google is on it, so you don't need to worry. But comparing it to Thihano and a bunch of Torch and all those other ones, TensorFlow is great. Yeah. You are.
I'm the developer, so especially to the data science.
Yes.
How easy is it to hack a machine learning system with treating a database and I'm such a into the negative
Yeah.
Is it not possible to feed it, incremental information and actually take it out?
Yeah, you can do what you want. You can tune the neural network into anything you like. If you want to do the opposite, you can train it to do that. What do you think?
I'm just thinking of process.
That's it. How do you prevent it?
How do you prevent it?
Yeah, how do you prevent giving it data that's actually going to give you a negative result?
Okay, with any neural network, you've got to make sure that it generalizes well. That's why you need training, test, actually validation, and then a test set is completely that the neural network hasn't seen during the training, because you can actually bias and skew the whole training thing if you don't have a proper test set as well. So, and then you need to make sure it's general. Well, there's always risks, but if you've got a neural network that, for instance, can generalize extremely well, you're going to reduce the chance for getting the opposite. And also, it's probability. The chances of getting an opposite.
It's not like hunts, for example.
Yeah.
I'm talking like feeding a data set that will, if it's continuously learning, it's dynamic. So you lose a little bit of control of what
Yeah, but the thing is, I think you're talking about online learning. The thing is, normally in neural net, you actually train, and once it's trained, you use it.
But doesn't it, like the graph show, doesn't it increase?
Now the thing is, once you are satisfied to a certain point, you actually stop training, and then you just basically feed it with examples that you want to, for example, classify.
That graph that you saw is just the performance on the data that you have, and so like how it works is you change the edges, the connections between the circles through time, and so as you do more of those iterations, you reduce the error on the data you have. It's just a question of how long you train the network.
I'm going to show you the test. That, for instance, is the test set. Everything the dark ones. You can see there's one that's on the peripheral there. That's very close to being the negative. So you do get that. And that's why on the test loss, the training loss, there's obviously we were training here for 907 iterations. But you can see that there is a little bit of an error still on the test side. 0.0, but the training was perfect.
So does live data never continue to refine the system?
If I could try and add my 2 cents to that. So I think the response to that would be in 2 classes. One would be when it's online learning, and the other one would be when it's
offline.
A discrete learning, which is then made live. And the way that you would control the two would be different. So for online learning, you would have the weighting of the recents and things like that. So you can control how sensitive it is to a recent malicious actor. But still, the recent malicious actor could still teach it something that you don't want it taught. But what could do in that case is, the one would be the sensitivity, which is how sensitive it is to recent events. And the other one would be, you could theoretically write test cases for it that sort of like checks a few outcomes that you expect to be there. And then monitoring and alerting interface, which tells you about that. When it's the opposite, so when it's not online learning, when it's discrete learning that you then make live, which is how Google does most of their models, you would, with each training session, there would be testing, unit testing, whatever type testing, before it's released into the wild. And in that case, the test cases that are there would be quite representative in order to try and catch any malicious actors. So I hope that sort of answers.
Yeah.
It doesn't seem to agree with AI, the concept of AI in terms of continuous learning and
All with it. There's so much improvement and stuff that's coming. So much.
For online learning, this is far from the theoretical concept. I think with Microsoft, we have to pull their online development from my team, but also communicate with your basic security.
That's it. Okay, the pizzas are there. Yes, question.
One question about TensorFlow. Does TensorFlow do like learning topologies or like safety weights or anything? So
there's actually, I think topology is an interesting area as well. But I just saw there's a tensor graph framework that's been created on top of TensorFlow, at least, where you can actually do whatever you like with the topology. stuff. But that's still fixed. You create it. And then the TensorFlow, as far as I know, is not going to create, well, there's drop-down and stuff like that you can do, but it's not going to, you're talking about building a network.
Yeah, you can learn the topologies on top of TensorFlow, so the sense to do can.
I haven't played enough of that.
So, with topologies, technically a deep network is capable of depending on the way you structure your data. So the more basic one, it's got to be
If you're just learning like a plane that separates the data points, it's doing it in 2 dimensions. Like it's just a question of generalizing to.
No, I mean like literally changing hidden layers and stuff and stuff like that. Because from what I've seen, it's like you need to specify
like network topology.
No, as far as I know, I don't think, because you do specify the graph.
Yeah.
And it just, so I don't think it allows that. So I can't, Anyway,
Genetic programming.
okay, it's just past 7. There's pizzas, there's beer, there's truth coffee, there's all sorts of stuff. We're stuck to an hour, so thank you very much for attending, and you're most welcome to stay. I'm going to be here. I know there's 1 or 2 people or more that want you to go, but I'd love to talk to you guys informally as well. So thank you very much.